So distribute means to multiply a term through to all the other terms. Everything inside the parentheses gets multiplied by the term on the outside. So let me show you how that works. I call this the rainbow method. So we're going to use this nice rainbow method here. We're going to multiply everything inside this parenthesis by negative 5x. I'm going to do it the long way. And then you guys will be like, why are we doing it the long way? I'm just doing it so you can see how it works. So we got 5x times 2x squared plus negative 5x times 3x minus negative 5x times 8. So each term, and there's 3 terms, gets multiplied by the negative 5x, and then we simplify. Negative 5 times 2 is negative 10. X times x squared is x to the third. Remember, we did that exponent rules. When we multiply the x at the same base, the exponents add together. So squared and a 1 power gives us a 3 power. Negative 5 and positive 3, when we multiply them together, give us a negative 15. X times x is x squared. Please note the difference between what we did in the last section, where we had to find the identical like terms to add or subtract them. That is not what we do with multiplying and dividing. When we multiply polynomials, we combine them together no matter what their letters are. If I have other x's, they come together and their exponents increase. If I have other y's, I can put them all into one term. So negative 5x times 8, negative 5 and 8, but I already have a negative, so that's a positive 40. And I have an x there. Okay. The same is true even when the number is on the right-hand side. Everything inside still gets the 5. So it's 9 times 5 minus 2b times 5, which means 45 minus 10b. So in this case, because I'm multiplying, I multiply the 2b times the 5 to get the 10b. But I can't add or subtract them. I can multiply them together all day, but I can't add or subtract them together until the exponents and the letters are exactly the same. All right, so now we're going to look at factoring. Factoring is the opposite of distributing. We're going in reverse motion of distributing. We pull out the greatest common factor of all the terms, and then we rewrite what's left inside of our parentheses. I'll pause for a minute so that you guys heard. I'm just going to go super duper long. All right, so I'm going to reduce these numbers down into their prime factors. So 2 and y, well, 2 is a prime factor. And if I had more than one, like if I had y squared, I would put y and then a y. And then 12, I'm going to kind of reverse it here. 12 is 6 and 2. 6 is 2 and 3. So my prime factors for 12 are 2 times 2 times 3. Okay, so we're going to underline what they have in common. They both have a factor of 2. They don't have any other common factors, so we're going to put the 2 out front. Once you identify the common factor and you put it out front, we're going to cross it off, because what's left is going to go in the parentheses. So I had a 2y, I took out the 2 and put it out front, so I just have the y. The sign is going to remain the same. And I had a 2 times 2 times 3, but I no longer have the 2, so I just have 2 times 3. which gets us 6. So think about finding the most common item. So let's go ahead and do the same thing for 3x squared. So this is 3 times x times x. So x squared means I have 2 x's being multiplied. The sign stays the same. 18 is 2 times 9. 9 is 3 times 3. So 18 breaks down into 2 times 3 times 3. And I have a times x hanging out next to it. So we're going to go ahead and underline what we have in common. Both of them have a 3, but just one. And both of them have an x. Unless they both have 2 of them, you can't underline 2. They both need to have that same amount in order to get an underline. Okay, so now I can see my greatest common factor is 3x. And once we write that down, we're going to cross those out. What's left goes in the parentheses. So I just had an x left here. My sign stays the same. And I have a 2 times 3 inside the parentheses. Very exciting. All right, so let's look at problem 1. We have a monomial and a polynomial. What kind of polynomial is this third one? Or is this guy right here? It's a trinomial, yeah. 3 terms means trinomial. Okay, so let's go ahead and rainbow out our negative x cubed. And plus negative x cubed times 7. So we're going to combine, everybody gets a negative x cubed. The signs, the pluses and minuses stay the same, but as we see negative and negative or negative and positive, we'll change it as needed. So this is negative 9x to the 7. Negative and negative give it a positive. We have a 2x to the 6 because we're adding our exponents together. Positive and negative give us a negative, and the number for that is 7. And we have an x cubed. Okay, take a moment and do the now you try. We're going to have, I haven't heard from Rachel. Rachel, I'm going to have you write the answer to the first one down. So if you want to check your answer with me before you write it down, that would be great. And then Juliet, I'm going to have you answer the second one. So if you're confident, you're like, I got this, and you don't need to check, you can just write it up. Or if you want to check, you can check that one. Answer to the first one.
Well, x squared.
What good? Didn't work? You guys check your answers to the now you try. Beautiful sentences, right? Why it's really like, I'm gonna own it. Okay, so check your answers. 15n to the 4th minus 5n cubed plus 40n. We got to make sure we're increasing each term by 1n. So if we had 3 to begin with, we're going to be 1 more up, so it's 4. If we had 2 to begin with, we're going to be 1 more up, which is 3. And we didn't have any to begin with, we're going to definitely have an n on our last term. Yay. Okay, so we need to find, so let's do the second scenario, find the greatest common factor, and then factor. So I'm going to split these up into their primes with you. So 5x cubed is 5 times x times x times x. 25 busts up into 5 times 5. And 45 busts up into 9 times 5, but also 3 times 3. So it's 3 times 3 times 5 times x. So you just want to break it up into the prime numbers. Then we're going to underline the ones they have in common. All of them have a 5. Yay. All of them have at least one x. Once you run out, because we ran out of x's on this 45x, we got to stop. So the GCF is 5x. So we're going to put that out front. Once we put it out front, we can cross it out. And we're going to write what we have left. So the first thing we have left is the x squared. The second that we have left is our 5x plus u. And the last thing we have left is our 9. Once it's out front, we can get rid of it. Maybe we are. Oh yeah. That pause in between where people were putting stuff up on the board, recorded. That's forward for that. All right, so let's take a peek at this next one. We got 13 and we got 5 x's. 26 is 2 times 13. And we have 3 x's. We are going to underline the ones we have in common. We both have a 13, and they both have 1 x. They actually have 2 x's. And in fact, they are sharing similar 3 x's. It's like they got triplets. So we're going to go ahead and pull those out front, the 13 and the 3 x's. Once we have it out front, we're going to cross it off. Then we write down what we have left. We have 2 x's left. That's an x squared. And we have a 2 left. You cannot do 2x squared. You can write x squared. But it's a plus 2, so they can't combine together because it's a plus. Okay, so you guys get a chance to try this. I'm going to have Scarlett have you do this one. Richard, I'm going to have you do this one. And Marissa, have you do this one. And then Diego, you get the big guns right here. This one right here. Okay, so when we look at the helicopter shape, we need to find the area of a square, and we need to find the area of a circle. The area of a square is its side s squared. The area of a circle is pi times its radius squared. And then the area of the shaded, hold on. That's pretty sure. The area of the shaded is the difference between the two. Area of the square minus area of the circle. So the area of the shaded is equal to the side squared minus pi times r squared. We're going to start putting those little pieces in. So this is equal to, so we take a look at our square. It's here, it's a 2x is our side length. So instead of 2x, so instead of x, we're going to put 2x. And we're going to square it. And we look at the radius of our circle. That's this item right here. That is equal to x. So instead of r squared, we're going to have x squared. Now we got to simplify this down. 2 squared is 4. 2 times 2 is 4. And x to the 2 power is x squared. Our pi doesn't get anything. And we have x squared here. Okay, can we see what they have in common without doing the factoring? You can't see what they have in common? You can't see, yeah. So we don't, in this case, because we can see it, we don't need to write that as x times x. So we're going to go ahead and write the greatest common factor out front. And once we write it, we can cross out that term above. And then just rewrite what's left over.